High-tech weapons. America has turned to high-technology weapon systems for several important reasons. They improve warfighting capability in an effort to convince a potential adversary not to start hostilities in the first place. If that fails, they can pinpoint military targets to rapidly break the aggressor's will to fight with minimum civilian casualties. They reduce Allied casualties, which is consistent with the American view of the importance of human life. A unique high-tech rotorcraft is being developed by the Department of the Navy for use by all services. It combines the hover and low-speed flight characteristics of a helicopter, allowing it to operate from any location with the high speed, high altitude, and long-range characteristics of an airplane. This unusual aircraft is called the V-22 Osprey. A 6-aircraft full-scale development program is well underway to qualify the Osprey for military production. Thousands of hours of wind tunnel tests, fatigue tests, static tests, system tests, and ground tests have proven the V-22 technology. Presently, 4 aircraft of the 6 prototypes are airborne, opening up the flight envelope and demonstrating the V-22's capabilities. In 1990, the V-22 reached major milestones by flying at altitudes of 21,500 feet and level flight airspeeds of 280 knots. In addition, the aircraft reached a speed of 349 knots, or 400 miles per hour, in a slight dive. To prove its ability to lift high gross weights, tethered hover tests demonstrated a vertical lift of over 15,000 pounds of useful load. The V-22 is more than a delivery vehicle. It has been designed from the ground up as a combat fighting aircraft. Its high speed is combined with a large payload, low susceptibility, increased survivability, advanced avionics, and night and all-weather capabilities to enable a maneuvering force to bring the fight to the enemy when and where we choose to engage. The warfighting features of the V-22 are a first for rotorcraft. Its high-tech design will enable forces to maneuver rapidly on the battlefield. History has proven that the ability to place concentrations of firepower where they are needed fast can prove to be the decisive factor in whether the battle is won or lost. The V-22's 250 to 275 knot cruise speed is 2 to 3 times greater than older helicopters. Its payload is 2 to 3 times higher than the 30-year-old helicopters the V-22 is intended to replace. Its range is 3 to 4 times greater than that of equivalent helicopters, allowing it to reach downed pilots deep in enemy territory fast. Without auxiliary fuel, it has a 400-mile combat radius. With auxiliary fuel, it can fly 2,100 nautical miles, enabling it to self-deploy around the world along standard air routes, freeing critical strategic air and sea lift assets to deliver troops, ammunition, and logistic supplies to the theater. Its 6x6 by 24-foot cabin with a rear ramp and cargo rollers allow 24 troops, 18 litters, or up to 20,000 pounds of cargo to be delivered quickly. On the battlefield, the V-22 is less observable than other rotorcraft. Its radar cross-section is less than comparable helicopters, and it has radar warning and chaff dispensers for protection. Its infrared signature is reduced with an efficient full-time IR suppressor. Its 1-to-1 dilution ratio and onboard countermeasures greatly reduce its susceptibility to IR missiles. The V-22 is one of the quietest aircraft in the world. Its slow-turning rotors greatly reduce the audio detection range of enemy ground observers. And this low noise signature, along with its high speed, reduces the reaction time available to enemy ground-air defenses. These and other observables have been reduced to enhance the Osprey's military value. Low-altitude overflights will be much safer for the V-22 than any other rotorcraft. If the V-22 is hit by small arms fire, it is much less likely to be shot down. The V-22's design has reduced the aircraft's vulnerable area to small arms to less than 1/10 that of existing helicopters. Critical flight control systems are redundant and separated so that a single round will not diminish the aircraft's capability. Critical drivetrain components are either shielded by non-critical systems or large enough to take a hit without failing. Low loads and vibrations reduce the risk of component failure, even if it is damaged. Many critical components are tested first by being shot with high-caliber weapons, then further tested to prove that the aircraft could safely return to base after sustaining battle damage. On an assault, strike rescue, or special operations mission, the V-22 would be more likely to successfully complete its job than any comparable rotorcraft. Older helicopter gauges have been replaced in the cockpit of the V-22 by 4 state-of-the-art high-technology color cathode ray tube displays, which can call up all flight and aircraft status information. All normal flight data is available to the pilot. Plus, the health of the entire aircraft can be investigated in flight to determine system and subsystem status. The crew can make mid-mission decisions about navigation waypoints and flight-critical components. The color displays are also used to display a forward-looking infrared system. It, along with night vision goggles, provides night and all-weather situation awareness for safe operations. Even in sand and dust environments, the combination of these systems allow low-level terrain recognition and horizon reference during low visibility. The color displays also provide a moving map display using digitized terrain to provide waypoint information to aid the pilot in flying exact air routes at low level, regardless of the weather and light conditions. Anti-icing and de-icing systems on the wings, rotors, windscreen, and engine inlets allow safe, continuous flight in moderate icing conditions. The V-22 has filtered air overpressure in the cockpit and cabin to protect its occupants from nuclear, chemical, and biological contamination. It is the only tactical transport with that type of protection. All openings are sealed to keep contaminants from entering the aircraft. Detection systems alert the crew to the presence of outside contamination. The latest Navy Marine evaluations of the V-22 were shipboard compatibility tests conducted in late 1990. 2 V-22s flew aboard the USS Wasp. While one conducted takeoffs and landings from various deck spots, the other shut down, folded its rotors and wing in under 2 minutes, and was placed on the ship's elevator for below-deck storage. The V-22 has a unique fold system. First, its rotors, index, and feather. Then 2 blades on each side fold inboard. The nacelles tilt forward into airplane mode, while the wing pivots on top of the fuselage. The entire aircraft is now as narrow as its landing gear tread, less than 18.5 feet wide. While below deck, various maintenance tasks were performed and clearance checks were made to show compatibility with the LHD class of amphibious ships. After several days of tests, both aircraft were flown ashore to continue development testing. The V-22 is a high-technology rotorcraft that is proving its value with each test flight. Over 300 flights, compiling more than 360 flight test hours, have been completed through January of 1991. The features in the V-22 are needed on the battlefield of the 90s and will be capable of handling the projected threats to U.S. interests well into the 21st century. It will join America's high-tech arsenal, dedicated to fulfilling U.S. interests while preserving our most sacred commodity, human life. It is a technology whose time has come, a unique American technology in aviation that this country can be proud to own.